Hello viewers, in today's video we are going to talk about a simple problem, or you can say a problem on calculating the theoretical production of methane from a hypothetical compound. So you can see in front of us we have the refuse. So this empirical formula is C99H149O59N. Okay, so here we will use the concept of Buswell equation. So you can see that the Buswell equation is a stoichiometric equation used in anaerobic digestion or stabilization of a waste. So this will foresee or tell you the theoretical amount of methane and carbon dioxide produced from a given organic matter. So here, if you take this CSHYOZ or CAHBOD, so the general formula if you have N here, suppose N, so you will take CAHBOZ or CAHBOC, okay, and ND or DN, okay, whatever you want to take, and then so it will release or it will form methane and carbon dioxide. If you have ammonia, so it will, sorry, if you have nitrogen, so it will yield or it will have on the reactant side ammonia, which is NH3. So this is the simplified form, and this is the balance equation. So here this term x minus y minus 4 is going to come from the balancing of the equation. So when you balance the moles of C on the right and left side, when you balance the moles or the atom on the H on the left and right hand side, or also when you balance O and the other terms on the left and right hand side, the coefficients which are attached to this, for example for the C it is x is equal to, for the carbon it will be x is equal to, so this is x is equal to 1 plus, so suppose this is some number, so it will be 1 plus this one, so this is A or B, whatever. So for H also it will be y is equal to, okay, this will be y plus something, 2 times of this is equal to 4 times of this. Okay. Similarly we'll balance, I mean on the left hand side and the right hand side. When we balance it, okay, so it will look like this, okay, it will look like this. So here the subscript, or here is 99, 149, 59, and then n is 1, okay. So here if you see this CAHBOC plus x times of water is equal to y times of methane plus z times of carbon dioxide plus d times of ammonia. Okay, now if we are trying to balance left and right hand side, so A here is equal to y plus of z, so we are just balancing the carbon. Similarly when we balance the hydrogen, so it will be B plus of 2x is equal to 4y plus 3d. Similarly for D, for nitrogen it is, for oxygen it is D plus 2x is equal to 2z. Similarly the nitrogen is almost same, so D is equal to D. Okay, now by solving these equations in terms of each other, so z is equal to c plus x by 2, y is equal to a minus z, so it is a minus c plus x by 2. Now we will be substituting into the each other, so x is equal to 4a minus 2c plus 3d minus b upon 4. Similarly y is equal to c plus x by 2 and z is equal to c plus x by 2. So similarly it will simplify, so y here is equal to 4a plus b minus 2c upon 3d upon 8, and similarly z is equal to 4a minus b plus 2c upon 3d upon 8. Similarly x is equal to 4a minus 2c plus 3d minus b upon 4. So this is the simplified formula, so you can substitute in the this term, okay, and then we will be getting this simplified form. Okay, so in the slides you can see here we have substituted y here, and then we have substituted, okay, okay, so here in the form of water this is 4a, okay, minus of b minus of 2c plus 3d upon 4. Similarly this is 4a plus of b minus of 2C minus of 3D upon 8, and similarly this is 4A minus of B plus 2C plus 3D upon 8, and this ammonia both sides is 1, so this will simplify to this one. Now what is important, we have to find out the theoretical production of methane. Okay, now this is a simple step that we need to follow, we need to understand is we will take the molecular weight or atomic weight of this compound. Okay, so this one, if we simplify, this total weight is equal to, because since carbon is 99, hydrogen is 149, so carbon will be 12 into 99 plus 149 plus 16 into 59 plus N is 14. So the total mass is around 2296 or 2297. If we take the whole weight, if we are taking the exact weight, precise weight, it made around 2300 also. So this is going to yield around 53 gram of the methane on the reactant side, the substrate. Now for the 1 unit, what we need to do is divide the total mass of methane, it is 53 into 16 upon total weight of this. Okay, so this will be around, mass yield of methane is 848. Okay, 53 into 16, so this gram substrate per gram of methane is equal to 2295 upon 848. Okay, so equivalently 1 gram substrate will be 1 upon 2.706, which is equal to 0.37 or approximately 0.37 gram of methane per substrate. If we are converting this into terms of STP, so we have to multiply by the 22.4 liters, because 22.4 liters at standard pressure. Okay, so it is 1187.9. okay, and similarly in the slide also. Okay, so they have taken this in terms of moles and divided by the any terms of moles of methane, and 1 gram of methane is 60 stage for 16 gram. Okay, and here we are getting 53 grams. Okay, so this is yielding around 51, approximately 0.37 gram. So either you can solve this way or you can follow this step. Okay, so this is the final solution. So in our next video we'll be solving another problem. Okay, another complex problem, this problem. Okay, where we have a municipal solid waste, and here the components are given, the weights are given, and here we have a cellulose. Okay, so here also same concept we'll be applying using the Bust equation theory or Bust stoichiometric theory. Okay, and then we'll be because since we have no ammonia here, so here the product, on the product hand side we'll be getting only methane and carbon dioxide. So stay tuned, don't forget to like and subscribe my channel.